is day 24 today. I'm just going to write that on my date. It is day 24. And it is Monday, September 15th, first period. And I'll call this my answer guide. So your directions were to pick one problem from each section and solve it. Make notes of the topics that you felt less confident in, and then we'll spend time reviewing those topics today before we do a practice quiz tomorrow. So I'm going to go ahead and remove that. And we're going to look at our first section. So in this first section, you are finding the area of a circle, and you're supposed to use your calculator's value for pi. So if you just type 3.14, you're going to get an answer that's just a little bit off. First of all, if we're going to be finding area, we're going to need the area formula. So I'm going to make a note of that. Area equals pi times your radius squared. So for the first four questions, are we given a radius or a diameter here? On all of these.
Radius?
Yes, we have a radius. Radius is that smaller measure. So it's also good to take note that if you are not given a radius, you're going to have to find the radius first. So for example, let's look at number 1. My radius is 10.6 inches. So if I'm using the area formula, pi times radius squared, what will I need to put in my calculator? What will I type? My formula is pi times radius squared. My radius is 10.6. What am I typing in my calculator? Yes, pi times 10.6. And I'm missing just one thing. Square. Perfect. And we can type that in all in a row. And remember, if you forgot how to get pi on your calculator, because it's one of those little blue keys, you're going to have to hit the second button first. So we hit second, and then it's just this up arrow under clear is where pi is. And now I have a little pi on my calculator. So I have pi 10.6 squared. Hit enter, and I got approximately 352.99. What would my units be? Inches. And since it's an area, will it remain inches or will it be inches squared? Squared. Good. So that is our answer for number 1. Perfect, perfect, perfect. Now, if I wanted an exact area, first of all, this one's approximate. We talked briefly about what we need to do if we have an approximate area. We need to put a little squiggly at the end. That's called the tilde. That means that it's not an exact answer. So if we want an exact answer, as a reminder, it's just going to be this exact same problem, the same formula typed in, except we're not going to include pi in the calculation. So all we have to do is type in the other half and write pi off to the side. So let's see 10.6 squared. Enter. 112.36. So your area exactly is 112.36 pi, didn't leave myself quite enough space here, inches squared. Now, on a quiz, you may be wondering, which one of these do I want? I am perfectly fine with either one. I will take either one every single time. If you give me an approximate one where you do include pi in your calculations, I would really like to see that tilde at the end. And I'm going to kind of highlight that and label to help us remember this is called a tilde, pronounced like Matilda. Tilde. And that just means we can make a little note, approximately. Okay. Now, before I give you the rest of the answers to check your work or to just have a key to practice later for numbers 2, 3, and 4, does anybody want to see another one of these worked out for more practice? Happy to show more. If we feel good, though, I can just give you the answer key. Up to y'all. Anybody want more? Okay, let me grab my answer key then. Number 2, if you did number 2, would be 530. And I'm only going to give the approximate ones here because that's what my answer key gives me. 530.9 kilometers squared. Approximate. That's number 2. Number 3, our answer for area would be 615.8 centimeters squared, approximately. And number 4, 254.5 centimeters squared, approximately. Okay, now we will work out one more from numbers 5 through 8 because now I'm given a different measure. Numbers 1 through 4, I was given a radius. I'm given half of the length across the circle. In numbers 5 through 8, instead of a radius, I'm being given a diameter. What do I need to do to find the radius? Because we need radius. It's in the area formula. How can I find the radius from a diameter? Divided by 2. Radius equals diameter divided by 2. Just another formula to keep in mind. So if I were to look at number 5, my diameter is 18 yards. What would my radius be?
Radius would be 9.
Radius would be 9 yards. Good. That's half of 18. So now that we have the radius, we'll do the exact same thing we did for numbers 1 through 4. Put that into our formula. Area equals pi times, don't use diameter, pi times 9 squared. And when I type that in, remember I'll hit second up arrow for pi. 9 squared. And I get approximately 254.47. I know the directions said to round to the nearest tenth. So if I were to do that, we could say 254.5. We'll go with that. So area is 254.5 yards squared, approximately. So that's the only difference between the first four and these four. Before I give you the answers for 6 through 8, do we want to see another example worked out, or do we feel good about this section? Area and circumference are a little bit more simple because we're used to plugging in things for formulas with area and perimeter. Makes it a little bit easier. So let's see. I'll give you an answer key. Number 6, your diameter's 22. So your radius is half of that, 11. And you should get 380.1 inches squared, approximately. For number 7, you'll get 314.2 inches squared, approximately. And for number 8, we'll get 78.5 miles squared, approximately. This is the first section done. Do we have any questions at all before we move forward? Going to page 2. Now we have something a little bit trickier. We're trying to find the circumference of each circle from an area. This was tricky. So we need a couple of formulas. I know that area is pi times radius squared. What is my circumference formula?
Pi. Well, 2 times pi times r.
Good. 2 times pi times r. Or you could also just do pi diameter. It's good to know that both ways exist. Both ways exist. So if I'm given an area, but I need to find circumference, we need to start thinking about what measure is it that we need to find in order to get a circumference. And I'm going to show you a worked out example for number 9. And then I'll have you guys kind of help me with it. So for number 9, I have been given that the area is 4 times pi inches squared. So I'm going to write that out. Area equals 4 pi. I'm going to leave out the units because if you put the units in, it can get a little bit more confusing. Let's make that not blurry. There we go. So area equals 4 pi. If I want to find the circumference, I do not have enough information here. I'm going to have to solve for a radius. So I know that area is also pi times radius squared. Here's what we're going to do. We're going to look at both of these two equations that I have written here, because that's what these are. These are equations. And I'm going to notice, what do they have in common? They both have pi. So if I were to remove the pi, maybe by dividing, let's do that. Let's divide by pi. And let's ignore the area. What we have left is 4 and radius squared. So I know 4 is my radius squared. I'm trying to solve for radius. Have I solved for radius yet? Almost. Almost. How can I solve for radius with this equation?
Square.
Opposite of square. It's already squared. Missing one word after square.
Square root.
Yes, 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 yes. When we solve an equation, we do the opposite to get rid of things. We need to get rid of squared. Radius squared is 4. So if I want to find radius, we're going to just square root both sides. What will happen is the squared will cancel, and now I have radius by itself. And now we just do the square root of 4. So if you forgot on your calculator how to do square root, remember that x squared button right here has that square root symbol above it. So you're going to hit second, the blue button, and x squared. Square root will pop up on your screen. And then I'm going to just type 4, enter 2. So 2 is my radius. Now that I know my radius, can I find circumference? The answer to that is yes, you can, because the circumference formula is 2 pi r. So what I'm going to do is, now that I've solved for radius, we're going to plug this number in. Circumference equals 2 times pi times our radius, which we found is 2. And this is this is a unique problem, because what we're going to end up with is we have a circumference that is the same as our area. I find that kind of interesting. 2 times pi times 2. If I want to give an exact answer, I'm just going to do 2 times 2 is 4 pi. If I want an approximate answer, we'll type pi in. 4 times pi, and you should get approximately 12.56. We'll round that up to 12.6. And that is inches or inches squared for circumference. Measuring a length around. Inches. It's just like perimeter. So we just need inches. Okay. Move that to the side. So that is number 9. I'm going to kind of split these up. And we haven't done as much with this particular process. So I'm going to work one more out with you guys, and then we'll see how we're feeling for the last two, 11 and 12. So to kind of simplify this process, because I'm looking at my work and it's a little bit unorganized, let's clean it up for number 10. What we're going to do, instead of writing out area equals the area they give us and area equals pi r squared, is we're going to kind of set the two equal to each other. I'm going to take this value, 16 pi, and instead of saying it's equal to area, we're going to go ahead and set it equal to the area formula. I know that 16 times pi is the same thing as pi r squared. So now that I have an equation set up, what can I do next? Yes, let's divide both sides by pi. We're trying to solve for r. So keeping that in mind, we want to try to cancel out everything around r. So we'll start by dividing by pi. And that just gets rid of it on both sides. And what comes down at the next step of this equation?
16 equals radius 2.
Perfect. 16 equals radius squared. And what would my last step be?
Square root of them.
Yes, square root of both sides. That's going to get rid of the radius squared and give us radius by itself. And let's find the square root of 16. Square root of 16 is 4. So now that I know my radius is 4, how can I find circumference?
2 times pi times radius.
Yes, circumference equals 2 times pi times my radius, which we just found is 4. So we can type that all in to get an approximate circumference. And I am getting 25.1 approximate. What would my units be? Feet. Good. 25.1 feet approximately. And if I wanted an exact answer, what would that exact answer be? Including pi. Take away pi, what's left? In my circumference equation.
2 times 4.
2 times 4, which is 8. So my exact circumference would be 8 pi feet. And you'll know that your exact is correct. You can check it by just typing it in. If I type in 8 times pi, I should get 25.1 approximately, and I do. So I know that that is correct. Perfect. Okay, before I give you answers for 11 and 12, do we want any more review Or do we want to run through 11 and 12 rather than giving an answer? If you don't want to run through it, you feel good about it, give me a thumbs up. If you would like more practice, pinky up. Okay, perfect. All right, number 11, our answer should be, an exact answer would be, let's see, 18 pi kilometers. Or an exact, or that is the exact answer, sorry, an approximate would be approximately 56.5 kilometers. Approximately, so those. For number 12, your exact circumference would be 14 pi yards. Your approximate circumference would be 43.98. Ooh, that actually would round up to 44.0. 44.0 yards approximately. So there is 11 and 12, if you're keeping track. All right. Now we're moving on to the trickier stuff. Near the end of the week, we started solving for central angles or arcs. So remember that the relationship between central angles and their arcs is that they are equal. So it doesn't matter if you're given an angle or an arc, the measures are the same. So just to draw a diagram to explain that, if I have a circle, I'm going to write down here central angles and arcs. If I have a circle that has an angle that comes from the center, first of all, that is a central angle. This angle, if we were to call it angle A, is equal to this arc that it creates, arc A. So if this is, for example, 80 degrees, we also measure the arc in degrees rather than inches or centimeters or whatever it might be. So just as a reminder, these are equal. So we also want to keep in mind that a circle is made up of 360 degrees total. And if I have a diameter, meaning a line that goes all the way through the middle of the circle, half of that circle is 180 degrees because we've got that straight line that's being formed. So these are all pieces of information that are going to help us with the rest of these problems here. So looking at number 13, the directions tell us we want to find the measure of the arc or the angle that is indicated, and assume that lines which appear to be diameters are diameters. So if they're going straight across, we know that they're going to make a 180-degree angle like we said here. So for number 13, we need to find the measure of angle ECF. Let's find ECF first. And I'm going to label it on my picture. Here's E, here's C in the middle, here's F. So I'm going to start by highlighting that angle. And I know that, what is ECF labeled with? What value do they give us?
15x plus 10.
Perfect, 15x plus 10. So I'm going to make note of that right away. 15x plus 10. Because I'm not just given measures, I'm given expressions, I've got variables, we're going to have to do something first. We're going to have to solve for x, then plug it in. So, looking at this circle, I know that ECF is 15x plus 10. What else do I know? What else do they give us?
DCE is 6x plus 2.
Yes, DCE is 6x plus 2. That's all they give us right now. What could I do to solve for x with these two angles? Any ideas?
Measure DCG would be the same as DCF.
DCG, so that's this one. Across from it, DCG is the same as ECF. Okay, so these are equal.
DCF would be the same as DCE.
Yeah, DCE, the orange angle I drew, is also going to be equal to GCF. These are vertical angles. They're across from each other. So we know that to be true. How can we use that to help us? This is where we'll need to think about the 360 degrees, or we can think about the 180 degrees. Do we have any diameters, any lines that go straight through the circle?
Yeah.
We do, from D to F. I'm going to mark that. We have a diameter right here. Since I have a diameter, I have half of a circle. How many degrees is half of a circle? It's 180. So I know that either half is equal to 180. We can mark that here. This equals 180 degrees. Now that I see this, is there an equation I could write?
No.
What equation?
15x plus 10
Mm-hmm.
plus 6x plus 2 equals 180.
Yes. I know that this angle, I'll call it orange angle, plus this angle, the one we need, we'll call it blue angle. I see that they form a straight line. They make up that diameter. So if I add them together, I can set them equal to 180 degrees. So I'm going to write that equation you just told us. We said 15x plus 10 plus 6x plus 2 equals 180. So there's my equation. Now that we have it set up, we need to solve it. How do I solve this?
Combine like terms.
Yes, let's combine like terms. 15x and 6x.
21x.
Good, that gives me 21x. And then I have 10 and 2. 12. So I have 21x plus 12. I'll bring down equals 180.
Minus 12 from 180.
Yes, minus 12 on both sides. We're subtracting from 180. I'll bring down 21x equals
168.
168.
And divide both by 21.
Yes, divide by 21. And when we do that, we've now solved for x, and x equals 8. Wonderful. Okay, so we've got x. X equals 8. But we want the measure of angle ECF.
It would be bringing back ECF 15 times 8 plus 10.
Yes, 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 yes. The last step, now that you have x, we need to plug that in to solve for ECF. So 15 times, instead of x, we'll do 8 plus 10. And 15 times 8 is 120 plus 10. So angle ECF is 130. Sorry, I should have let you say it. 130 degrees. That is our answer. That is our answer. So for these problems, you have two major steps. Step 1, solve for x. Step 2, plug it in to solve for the angle or the arc that they asked for. So might be a good note to make. Solve for x. That's the first step. Second step, plug in x to find angle or arc. Those are your two steps for these problems. Okay. Let's look at number 14 because this one is different. First thing I like to check for, obviously, is, what do they want us to find? So let me do that first. We want the measure of the arc JI. Now, instead of looking for 3 points and seeing what angle, we're just going to find J and I, and it's right here, J to I. Now, remember, since it's a central angle, that arc is the same measure as the angle inside. So what is the value for JI that they give us?
X plus 97.
X plus 97. Good. So just like on number 13, I'm going to write that value up at the top so that I don't forget. That's what I need to plug into. JI is X plus 97. So now that I know what I want to find, I'm going to look at my circle, I'm going to look at my angles and arcs, and I'm going to ask myself, what do I notice? Are there any diameters? Are there any angles that are equal? Are all my angles labeled? What are we thinking for number 14? What's going on here?
Have to add all values up to 360.
Yes, yes. Every single angle is labeled. If every angle has a value, we have an easy way to solve for x. We just add them all together. And since it's a whole circle, they equal 360 degrees. So I'll make note that all of these added together equal 360. It's a whole circle. So the only part that can be tricky with these is making sure you don't leave any values out. So if it helps to highlight them or circle them in some way, I can see somebody forgetting that 30 degrees possibly. So I know I have x plus 97. I have minus 17x minus 2. I also have minus 17x plus 4. And I also have 30. So I'm going to write all of those out and set them equal to 360. Now to save some space on my paper, I'm going to stack them up. So I'll start with x plus 97 negative 17x minus 2. Negative 17x again, plus 4, and then plus 30. And we can combine like terms this way. So I have x by itself. What is that invisible number in front of the x? There's no number. Don't forget that this is still 1. So I have positive 1, minus 17, minus 17. Let's see what that gives us. 1 minus 17, minus 17. And I got negative 33 for my x. I've combined my x's. Now let's look at our non-x values. I have 97 minus 2 plus 4 plus 30. We can type it in all at once if we want. So that's what I'm going to do. 97 minus 2 plus 4 plus 30. And I get positive 129. So I'm going to write plus 129. And what is that equal to?
Yep, 360.
Yep, 360. Still 360. So now I have an equation. All I got to do from here is solve it, and I'll have my x value. So we'll continue that. We'll subtract the 129 from both sides. I'll bring down negative 33x equals 360 minus 129 is 231. What would my last step be?
Divide both by negative 33.
Yes, divide both sides by negative 33.
X would equal negative 7.
Perfect. X equals negative 7. So we have an x value. Is that what I need?
Nope.
Nope. I need it, but it's not the end.
What you take now is basically measure with J, which would be x plus 97. What's x with negative 7? Would be negative 7 plus 97.
Perfect. So we just need to take that x value we solved for, plug it in to that value we put to the side. That's why I think writing this off to the side is really, really helpful, because once you've solved your problem and you've written all over your circle, if you're like me, I'm not even going to remember what JI was. So I'm glad I wrote it down. So I have negative 7 plus 97, and that gives us what?
Gives you 90.
Yes. JI is 90 degrees. Which is tricky because they didn't give us a little box, but that would almost be cheating. That'd make it too easy. All right. JI is 90 degrees. Okay. Now, this was the topic in particular that I feel like last week, just as a class, this one gave us the most trouble. So we'll probably focus a little bit on this today unless we're feeling better about it. Of course, this and segments, which we haven't gotten super far into. We've only done a problem or two with segments. Before we move on to the segment section, though, would we like more review with this? Would we like to go over any of these in particular? Let's just take a peek through each of the problems. let's see, number 15. I'm given a value for this angle, for this angle, for this angle. This one angle doesn't have a label, but do I know the measure of this RVS? Does anything tell me what this measure will be?
Be equal to for the angle of UVT.
Yes, 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 yes. That arc right here tells us that these are equal. And UVT is 9x minus 10. So that's what RVS must be. Once you have all your angles labeled, now they are, you can solve this problem exactly like number 14. And I'll give you an answer for that one. So in case you decide to go back and do it later, you'll have a way to check your work. Number 15, after you solve it, you should get that angle SVR is 80 degrees. That's for number 15. For number 16, again, all of our angles are labeled, so we can just add them together, set them equal to 360, just like the last one. And if you do decide to work this one out, the answer for the angle TUS should be 160 degrees. Okay, before we go to the next page, do we have any questions about these problems? Okay, so flipping to page 3. Now there's just more problems, just like the ones we just did. So I will make sure that we feel okay about them. 17, all of our angles are labeled. We can set it equal to 360 to solve. And your answer for the arc HF, if you decide to work it out, you should get 140 degrees. Now for number 18, we have something a little bit different. So before I just give you an answer, I just want to make sure that we would know what to do here because all of my angles are not labeled. What do we notice about this circle that the last few didn't have?
Has a diameter.
It has a diameter. It has a line going straight across. If I have a diameter, what do I know about this non-labeled side? What measure could I give this side of my circle?
80 degrees.
180 degrees. So I know that this is equal to 180. I know the other side is equal to 180. You could either add all of them together and include 180, set it equal to 360, solve, or you could not include the 180, set these two, add together, equal to 180. Does everyone feel okay about that one before I give you an answer? Okay, so number 18, if you do that one, you should get that the angle XZW is 66 degrees. Number 19, you have all of your angles. That'll be when we equal 360. Number 19, your answer, if you do work it out, is that the angle MIN equals 40 degrees. And number 20, This one could be tricky. 20 is definitely a more difficult one because I have 3 angles that I do not know. So I think we should look at this one. So for number 20, I'm looking for the measure of angle GJF. On my circle, I see G is here, J's in the middle, F is here. I want to know this angle. That's what I'm trying to find. I know that this is 49x. I kind of covered it up, so I'll write it again. I know that this big section here, EJI, that's 130x plus 1. What else do I know?
IJH is also 49H.
Yes, IJH is 49x. It's got an arc. Anything else?
I mean, that HGJ is also 49H?
Yes. These 3 angles have arcs, so they are all the same. They're all 49x. So now I know everything except for what I'm missing. Any ideas of how we could at least begin to solve for x?
You add all 49 X's all together,
You could do that. What would that be equal to? Do we know?
equal to 147. Then I guess you minus
We don't want to do anything unless we're certain that it's equal to either 180 or 360. That's where I would start. Since I don't have every angle labeled with some value,
oh, okay. The diameter would be this line from IJF would be your diameter, instead of splitting that in half.
yes,
Make the side with 130x plus 1.
Yes.
And x equal to 180, so equation would be 130x plus 1 plus 49x equals 180.
perfect. All I can do is set things equal to 180 or 360. I don't have the 360, so we have to use 180. This is a diameter, it's half the circle. So if I can solve for x, I can use that to help me find other things. So one thing at a time, we'll solve for x. We're going to write that equation you just gave me. 130x plus 1 plus 49x equals 180. And then we just go through the same process. We combine like terms. So let's see, 130 plus 49. I get 179x. Bring down plus 1 equals 180. Subtract 1. 179x equals 179. What's my x value going to be?
1.
1. Good. Those end up essentially canceling out. We get x equals 1. Now, here's where this problem gets especially tricky. I don't have a value to plug into to find GJF. Don't have something to plug it into. So, I do have other things to plug into, though. Do I have any other diameters in this circle?
There's one for EJH.
EJH. Yes, this is a diameter right here. So we also know that these three angles are 180 degrees. If I knew what the number value, how many degrees these two angles were, could I use that to solve for the angle I need?
Yeah.
Yes. How can I? Go ahead.
Combine both the 49s and both x's, so basically the 49 times 2,
Hmm?
which is 98.
Yes. Let's see.
Plus
49
2
x
x's.
basically times 2 equals, you said 98 x. Okay, so I have 98x, and I know what x is. It's 1.
98 degrees.
So we have 98 degrees between these two angles. So 98 plus whatever the angle is here that we need should equal 180, right? So let's set that up. I'm going to call this what it's called, GJF. So I know GJF plus 98 equals 180. Just solve the equation, subtract 98, and we'll have our answer. So what is the measure of angle GJF?
82.
82. Very good. 82 degrees. So I'll write that up here at the top. Angle GJF equals 82 degrees. All right, so we've gotten all the way up to number 20. It is 10:32, a little bit past when I normally give you guys a break. For the rest of this worksheet, we are going to review more of that after we take a little break. So it is 10:32. It'll probably be 33 by the time we start our break. Let's shoot for coming back to start again about 10:45 at the latest. 10:45. That gives you a little under 15 minutes if you need to stretch your legs, bathroom, drink, whatever you gotta do. And I will pause this recording and we will resume after that. All right, we are back and now we're looking at segments. We're not looking at arcs and angles anymore. So remembering back to last week on Thursday, this would be a great page of notes to get out, day 23 notes. This is whenever we wrote down and drew some diagrams that go with certain formulas for our segments. So if you do not have these formulas, you won't be able to do these problems. I do have copies of this note page. If any of you need it, speak up and I'm happy to give it to you. So first, we'll just kind of run through some of these. We'll look at number 21. Before we can solve for anything, we need to think about whether this is showing exterior segments where we have parts coming out of the circle, or if all of our line segments are inside and they are interior segments. Number 21, these are all inside. These are interior segments. So we're going to be using the interior formula. A times B equals C times D. So I'm going to write that formula off to the side. A times B equals C times D. And we're trying to find the measure from Q to J. So I'm going to mark that first. What is the line segment from Q to J labeled as? Here's Q, here's J. This one? Yes, 1 plus 5x. So just like all the angle problems, that's a value I will need later. We're going to solve for x and then plug it in to find that. So I'm going to write that off to the side. QJ equals 1 plus 5x. Now, I think the trickiest part of these problems is writing your values in the right parts of the formula. So I like to start with A, and we can choose any part to be A, but whatever we choose as A is going to affect the rest of the problem. So I'm just going to start with that 1 plus 5x being my A. If this is A, remember that we always follow that line. Keep going straight, don't go up or down. Whatever is beside that is a different color now. Well, this 15 from Q to L, is this going to be labeled as B, C, or D? What do we think? Here's our picture. Whatever line I start with, luckily these are labeled B. Good. It's kind of in alphabetical order here. Whatever I start with for A, the line that is directly connected right next to it, that's my B. Then we just start back over for C and D. So I know A is 1 plus 5x. I know B is 15. What would C be labeled as? 3x plus 1. Perfect. That is my C. And D is the only thing left, 24. So all we need to do now is put these in our formula. Now, I hope that I haven't given you problems that are too mean or you'll end up with a quadratic. Let's see. Okay, so if it's A times B, let's do 1/2 of the equation at a time. A times B. We're going to plug that in. 1 plus 5x. That's A times B. So times 15. So I have 1/2 of my equation done. I just need to write an equal sign. And we need to plug in C times D. And we said C was 3x plus 1. And D is 24. And these are multiplication problems. So when we have values like this and we're trying to multiply, we don't often see the regular whole number on the right side when we're multiplying. Oftentimes we'll see it on the left side, and it turns into a distribution problem where you're still multiplying, but you're multiplying by more than one thing at a time. So if you're looking at this and you're thinking, okay, I see how you plugged those in, but now I'm stuck. I don't know where to go from here. Watch, and I will show you. So I'm just going to look again at one half of my equation at a time. I have a times b, or 1.5, or sorry, 1 plus 5x times 15. When we have a problem like this, we are still multiplying, but we're distributing. Normally, you'll see it written the opposite way, where it might be more like the 1 plus 5x is here, and the 15 is here. Does this look a little more like something we can do? Yeah. We're just going to distribute, which again means multiply. So 15 times 1 is 15. 15 times 5x, see what that gives us. I'm getting 75x. So I have 15 plus 75x after I do my multiplication, my distribution. And we'll do the exact same thing on the other side. So I'll bring down equals. And then I'm going to flip-flop these again just because it looks a little better in my brain. 24 times that 3x plus 1. So I've got one side of my equation multiplied and distributed. When somebody else gets this second half, tell me and we'll add it in. We've got 24 times 3x. What will that give me?
72x.
Good, 72x. And what's the last term here?
24 times 1 equals 24.
Perfect. 24 times 1 is 24. And now we have a slightly less scary equation. Now this can still be a little bit tricky because there's not many problems on the previous pages where we have variables on both sides. This might be super easy for you, and that is wonderful, but it never hurts to review because we get really used to combining like terms by just adding them together. But we can't do that here because there's an equal sign in between. How will I combine my x's? How can I get these on the same side?
Minus 72 on both sides.
Yes, we're gonna subtract 72x over here and on the other side as well. That's gonna get our x's all on the left side of the equation. It's gonna cancel my 72x. And then let's see what happens. 75x minus 72x. I believe that leaves us with just 3x. We'll bring down 15 plus 3x equals, all that's left is 24. We are here. What do we do next?
Minus 15 to 24.
Perfect. Minus 15. Bring down 3x equals 9. Good. Divide by 3, that'll give us x. 3. Good. So x equals 3. I'm going to write a note. This is number 21. Okay, so now that I have x equals 3, remember we're still trying to find the measure of qj. And luckily we labeled that earlier as 1 plus 5x. So how can I use this x value to find qj?
1 plus 5 times x, if you place the x with 3.
Yes, plug it in just like the other problems. 1 plus 5 instead of x, we're taking it times 3 because x is 3. And I do not want to see anybody do this. Do not do 1 plus 5 first. Order of operations. Multiply first. You will get the wrong answer. 5 times 3 is 15. Good. Bring down plus 1 and we get 16. QJ equals 16. That is number 21. Very nice. Scoot that over a little bit. Make space for 22. Now, I know this one was a long problem, so I can leave this up for a minute if anyone is still writing. We'll be looking at number 22, which looks a little bit less complicated. There's only one X in there. Okay, so for number 22, will I be using the same equation as 21? The A times B equals C times D? Or will I need a different equation? To make sure we're using the right equation or the right formula, that's a better word, formula. Make sure we have line segments that are all inside the circle. If I have any exterior segments, then I'm going to need a different formula. This is the interior formula. Do I have any exterior segments here? No, you're right, we don't. We don't have any. So we're going to use the same formula. A times B equals C times D. So it does not matter which value we choose, but it will affect the rest. What do we want to use for A? Oops. 4 options there. I'll go ahead and take for you. I'm going to use the same layout as the last problem. I'll go with A here for 6. So this other 6 is our B, which means we go back and C would be x minus 2, D would be 9. And at the end of all this, we want to find MK, which this one's a little different now. From M to K, that's the whole length across the circle here. So MK is going to be not just x minus 2, not just 9. How do I put those together? Do you have any ideas, or are we not sure? Over here, I was able to just write QJ is 1 plus 5x because it was just this part. But for example, if I needed J to L, this whole length, I would have to add the 15 on as well. So JL would be 1 plus 5x plus 15. And then we just combine our like terms. We get 16 plus 5x for JL. So with that process in mind, how would I find the value? I don't know the length yet, but how would I find the value that I need for M to K?
Two of those basically, so like two x minus twos and two nines. Add together.
You're so very close. I only need this one line. I do need both of these values, but if I did two of each, the line would be twice as long. What's in between half and double? You just need one. You just need one. I need this length. So I want exactly what's labeled. I want the 9 and I want the x minus 2. So we're just going to use one of each. We're going to add those together, like over here. Does that make sense why we're doing it that way?
Yeah.
Okay. Good. I want to make sure I'm making sense. So MK equals x minus 2 plus that 9. That's that whole segment length together. And we could just leave it like this. But if we wanted to kind of combine our like terms, we've got a -2 and a +9. We'll get that MK equals X plus what? 7. Good. So we know that this is what we're going to plug into at the end once we've solved for X. So I have MK is X plus 7. So I have my A, B, C, D labeled. I know what MK, the value for it is. How can I find the X that I need? What equation will I write?
A times B, C times D, which would be 6 times 6, equals x minus 2 times 9.
Perfect. So A times B is 6 times 6. Equals C, we said is X minus 2 times D, we said is 9. Now we can start solving. So we'll go one side at a time. What is 6 times 6?
36.
36. Good. Equals. What do I do to multiply these two?
Distribute.
Yes, distribute. So 9 times x gives us 9x. 9 times minus 2, -18. So now I have 36 equals 9x minus 18. Where would I go from here?
Add 18 to this.
Perfect. Add 18 to both sides. So you're adding to 36. And let's see. 36 plus 18. Perfect. 54 equals 9x. One last step. We'll divide by 9. And we get x equals 6. Good. X equals 6. Now that we know x, can we find MK?
Yep.
Yes. Plug it in. Perfect. MK equals, we said it was x plus 7, so let's plug in 6 plus 7, and we get 13. And that is it for 22. So once you know the process, these aren't too difficult. Sometimes they take a little bit because there's a lot of steps there, but y'all got this. Got this. Okay. Does anybody need to see this still before we move on? All right. So number 23 is just like the last two. I will give you the answer so that if you decide to work it out later, you can check your work. 23, the measure from T to V is 12. Suddenly 24, we have something different. Will I still use the interior segment formula for number 24? Are all my segments inside the circle? No, they are not. They absolutely are not. So I need to look at my note sheet and decide which formula to use. As a rule of thumb, we can think of it like this. The first formula has A, B, C, D. So there's 4 segments labeled. My second formula only has A, B, C. There's 3 segments. And my last formula, A equals A, there's just 2 segments. So sometimes looking at the picture, it can be hard to compare, especially when we have different angles. This doesn't look like any of those. It can help to see how many segments do I have labeled and go off of that. So on number 24, how many segments do I have labeled? And 1 here, x minus 3. 2, there's a 3 labeled. 3, from M to N, I see 4. And then from N to H, x minus 6, I see 4 labels. So I have 4 segments. So we need this formula. A times A plus B equals C times C plus D. So I am going to write that out. Keep in mind that we are going to be using that formula in particular. So A times A plus B equals C times C plus D. And just like the last 2 that we did, start with A, whatever you choose for A, B is right next to it. Then start over at C, D is right next to it. Now we do want to be careful in how we label. I'm turning it to the side like this to match my picture. What is the most reasonable measure that we would call A? What makes the most sense?
4.
4. Yes, 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 yes. I'm going to call 4 my A. So what's B?
6.
X minus 6. That's B. What is my C?
3.
3. And so all that's left is D, X minus 3. Okay, so I have A, B, C, D labeled. Done. Let's plug them in. Now this one can be a bit trickier to plug in because the formula is a little bit longer. So we'll start with A's. Under each A, I'm going to write 4. 4. 4. And that's it. Plug in B, which again is X minus 6. So instead of B, I write x minus 6. So what we have so far is 4 times 4 plus 4 minus, or sorry, x minus 6. 4 times the quantity of 4 plus x minus 6. That's just a and b plugged in. Next we have c, which is 3. And c again, 3 again. We'll plug in d, get x minus 3. Okay. Before we work it out, is anybody confused about how I got these formulas or these numbers plugged into the formula? Okay. I have it all plugged in. I would like you guys to try to solve for x. I will quietly work it out up here. When any of you have an x value, raise your hand and let me know. And I'm going to pause this recording while I let you guys work on this for a minute. I want to see if you guys can solve for x on your own with an equation that's a little complicated. And as I write my workout, I'm kind of double checking with what you're writing and compare it to what I'm writing. Make sure that even if you did it differently, you're still on the right track. I'm going to write out 2 different ways you could have done this. The way over here on the worksheet is where I decided to combine like terms before I distribute. Now I'm going to show you another way as well, over to the side. And we'll talk about both here in just a minute. I've got two different ways of solving for x written down. They both give me the same answer. Did any of you, first of all, is anyone still need more time? Anyone still solving? Okay. Did any of you find x in a different way than how I did? Or do you feel like your work was pretty similar to one of the methods? So I'll explain the difference between the two, and we'll talk about why both work. You'll get the same answer as you can see here. Basically, in this method here, where I've solved it in orange, I decided that doing a distribution problem where I multiply 4 times 4 times 4 times x plus 4 times -6, that just felt like a lot of steps to me, a lot of multiplication. So I can use my knowledge of combining like terms, and I know that PEMDAS, my order of operations, tells me I can do things that are in parentheses first. So I decided to combine 4 plus -6. I carried down my x. 4 plus -6 is -2. Then all I have to do is 4 times x and 4 times -2, rather than 3 terms. Then over here I notice I have 3 plus x minus 3. 3 minus 3 is 0. So those 3's actually can cancel. And then I just bring down the x. From there we get 4x minus 8 equals 3x when I multiply. And then I solve for x the rest of the way here. Now, in this problem, you'll see I did not combine like terms. I decided to just leave what was in parentheses, all 3 terms here. And I get bigger numbers. The problem might take a little bit longer this way, but as you can see, I got the same exact answer. It still works just fine. So there is our value for x, but that's not all we needed, right? We want to find kn. Now, on the other problems, we usually marked what we needed to find first, but I forgot to do that. So let's find that. What is the value? I don't know what it is yet, but I know what they give us. What do they give us from k to m?
X minus 3 times 3.
X minus 3. Now, if I take that times 3, I means that I'm taking x minus 3 and another x minus 3 and a third x minus 3. We're just going to add the 3. So it'll be x minus 3 plus 3. You're very close, though. Very close. So I want to mark that to the side. Km equals x minus 3 plus 3. Now that I know I'm going to be adding x minus 3 plus 3, when I combine my like terms, what is Kn equal to? Bless you. Happens with minus 3 and plus 3.
Equals 0.
Equals 0. So Km is just x. We know what x is. It's 8. So what is Km?
8.
Km is 8. Perfect. Perfect. Okay. Do we want to see any more examples worked out of problems like this where we have exterior segments. Thumbs up if you feel good about it. If you don't want to see more, pinky up if you would like to see more. Okay. Alrighty. Well, here is what we will do. That is essentially all the topics that we will have on our quiz. Tomorrow we will do a practice quiz. Today you will have an exit ticket. And because the segments are the most recent thing we've done, that is what your exit ticket is going to be covering. So what I'm going to do is I have your exit ticket about halfway made right now. I need to put one more problem on there. I'm going to run copies and then I will be back with that in a minute. We still have, let's see, it's 11:27, 11:30. You guys still have a good 25 minutes to finish this exit ticket once I run copies of it. But that's our review today. So I'm going to go ahead and end our recording. Just keep in mind, practice quiz tomorrow. Stick around and wait for copies of the exit ticket. And I will show that on this video as soon as I finish it. Give me about a minute and I'll have that ready. Here is what your exit ticket will be. I will leave this up on the screen and keep it frozen so that you guys can see this. And if you're wanting to begin on it before you get your copy, you are welcome to do so. But give me about a minute here and I will run copies for you guys. And I will be right back. And that is it.